let's take a look at the Rotor. So the Rotor is an old amusement park ride, and it consists of a big rotating cylinder. And in this ride, passengers are on the inside of that cylinder. And the way it works is as it rotates, the passengers are stuck to the side. They don't slide down. They just kind of seem to float there when you're watching it from the outside. Now, this ride has lots of different names. When I was growing up at King's Dominion, they called it the Time Shaft. But you don't see them around very much anymore. The last time I saw one was in 2004 in Oklahoma. It was at a traveling circus, and I did not ride it because I wasn't sure if the bolts were all put together, and I was kind of afraid it would fly apart. But anyway, I'm going to link to videos of the real thing in the description of this video, so you can take a look at real Rotor rides. So as this thing spins around, the passengers don't slide down. That's kind of odd. So let's think about why that would happen. Let's consider the forces on a passenger in the Rotor. So there's going to be a gravitational force downward. And let's think about the other forces. Well, there's a force toward the center because the person is traveling around in a circle. So what could be the centripetal force here? Well, the wall is right there. The centripetal force is the normal force. Okay. And the person does not accelerate downward, so there has to be a force balancing the weight. What would balance the weight? Well, the reason why the person doesn't slide down the wall is because of friction. Friction is the upward force in this situation. And that makes sense because friction is always parallel to a surface of contact, and it opposes motion. So yeah, friction force is upward. So in this ride, when everything works, the gravitational force and the friction force are balanced, and the normal force is the centripetal force. And we have one extra connection that we can make here, and that is that we have a relationship between the static friction force and the normal force. And here it is. Static friction force must be less than or equal to the coefficient of static friction times the normal force. So the three kind of equations that are going to describe the rotor when it's going around is that the friction force is equal to the weight. And here, of course, we're talking about magnitudes. I'm ignoring direction. The normal force is equal to the centripetal force because it is the centripetal force. And the static friction force is less than or equal to the coefficient of static friction times the normal force. All right, so let's try an example. Let's say that we have one of these Rotor rides, and it has a radius of 4 meters, and it rotates with a period of 3 seconds. And I'm going to ask 3 questions about this. What's the normal force on a 35 kilogram passenger? That's like a normal mass for a child. So what's the normal force on a 35 kilogram passenger? And what's the minimum coefficient of static friction to not slide down when this is rotating? All right, so let's figure that out. Well, if I want to figure out the normal force on a passenger, I know that the normal force is the centripetal force in this situation. So if I can find the centripetal force, I can know the normal force. Well, the centripetal force, I got a bunch of different equations that allow me to figure out the centripetal force. And centripetal force is equal to mass times centripetal acceleration. And centripetal acceleration, well, if I look at the information I have, r and t, centripetal acceleration is 4 pi squared r over t squared. So all I got to do now is plug in my values. And if I plug in the values, I find that the normal force on a 35 kilogram passenger would be 614 newtons toward the center. And just as an aside, let's figure out how heavy that really is. So usually, if a 35 kilogram person were standing on the ground, the normal force on that person would be 343 newtons. So a person in this ride feeling 614 newtons of normal force would feel pretty heavy. All right. And B, the minimum coefficient of static friction to not slide down. Well, the friction force has to be less than or equal to the coefficient of static friction times the normal force. If we rearrange that, we get this. The coefficient of static friction has to be greater than or equal to the friction force over the normal force. Well, the friction force is balanced by the weight. The weight is 343 newtons, so the static friction force has to be 343 newtons. And the normal force is 614 newtons. So the coefficient of static friction has to be greater than or equal to 0.559, which means that the minimum coefficient of static friction is 0.559.